Hello, welcome, and thank you for attending our presentation. I'm Corentin. I'm the lead Houdini artist at Apple Studio, and I'm basically in charge of spawning a lot of the maximum of content procedurally in our open world.
Hi, I'm Quentin, lead tool programmer at Apple Studio. I'm in charge of everything related to automation and cross-project tool development. Let's first have a look at the table of content. So first, we want to speak about Outcast license that we are working on at Apple Studios. Then, as a second point, we want to discuss about the open world that we are building with few numbers. After that, we will discuss about how we started working with Houdini and few challenges that we faced at that time. The first point will be that we want to discuss about Houdini tools and give you an overview of them, but also how they are connected to each other through outputs. After that, we will discuss a bit about pipeline, how everything is connected, what is hidden behind the scene, because on our side, we spend a lot of time as a small studio working on that, so it's valuable information. And then the last 3 points will be the in-depth of all the several tools that we worked on. First, we want to say that it's a spoil-free talk because we will only show the world trailer that is already available online. So yeah, if you don't want to see that trailer, for sure, yeah, leave the here. Otherwise, all images are work in progress because the game is not out yet. So you know how production works. Like, it's changing all the time. We have still have a lot of work to do. So yeah.
Let's talk a bit about Outcast license. Outcast was created in 1999 by Apple Studio and published by Infogrames. For those of you that didn't play the games back in the days, it was a third-person adventure, and it was the game was composed of multiple open areas, and in order for the player to go from one to another, he had to take the portals. And the game was pretty innovative back in the days, thanks to the voxel technology that it used for the landscape.
Sorry. In 2019, Apple Studio and THQ Nordic revived the license, and they decided to create Outcast 2: A New Beginning. This is a seamless open world, so it changed a bit, but we are keeping the same codes than Outcast 1, but we are modernizing everything with Unreal Engine 4 technology. More than 50% are working on that game every day, so we are not a super big team, for sure. We want to show you now the world trailer to give you a bit of an overview of what we are building.
So now let's talk a bit about numbers in our open world. Our world size is 64 square kilometers, and we have 256 landscapes, and we have more or less 30 layers that we can paint on the landscapes. We have 5 biomes and multiple sub-biomes in order to have a lot of variation inside our environment. We wanted dense vegetation. While we were working on this presentation, we noticed that we had almost 100K foliage per landscape, which means that we have almost, we have 26 million foliage in all the world. We have more than 120K rocks and trees as a static mesh placed in the world. Here, without giving you numbers, because as we said earlier, we are spoil-free and we don't want to share too much data, but basically we have a lot of living form inside our world. They are both hand-placed and procedurally placed in the world. And finally, we have a lot of iconic and gameplay areas, such as the villages, the temples, shrines, or even enemy bases. So now let's talk a bit about how we started with Houdini and the challenge that we faced. One of the first big challenges that we faced is that when we started the project back in 2019, we were a pretty small team, and we didn't have any Houdini artist that was working on the team. We neither had any dedicated tool programmer. When we started the prototype, that was only one landscape, we started to paint the foliage by hand, but we quickly noticed that it was an almost impossible task if we wanted to have a big open world. So we began to search procedural solution. At the start, we looked at Unreal procedural tools, but we noticed quite quickly that it was too limited for our needs. So we had a look at Houdini. Even without any experiences with Houdini, the first week was already pretty successful in terms of speed and quality. As you can see on that screen, on the left, we spawned a lot of stuff which are represented here by boxes inside Houdini. And on the right, you can see the visual representation of it inside Unreal. So even if the quality was pretty basic at first, we quickly noticed and knew that Houdini had a real great potential for us to build a big open world. The outcome of that is that one person can fill by himself a landscape, which is pretty amazing. The visual quality would increase because it brings consistency. And finally, when some artists created new foliages or new assets, it was very easy for us to implement it inside our Houdini tools.
Well, the second challenge that we had to face is the procedural generation for the entire world. We have 256 landscapes, and at a point, we questioned ourselves, okay, how can we generate all that automatically? So back in the days, PDG, it's maybe a solution, but it was not available, so we decided to create our custom pipeline solution to build that on servers. World composition is what drives level loading inside Unreal. So, and when you create a map from world machine and then put that inside world composition, you receive different types of levels, and all those levels store each landscape. Basically, when you start working with that, you receive coordinates, so X and Y coordinates. And we decided to stick most of our of our levels based on that convention. It helped us a lot, because our pipeline system can easily find all those scenes based on that convention of coordinates. The outcome of that research phase, we had a pipeline first, and we could automate everything by night with batches. The second outcome is that we could rebuild based on a specific coordinate, and we could decide which coordinate to rebuild. And the last one is that artists or Houdini team could relaunch a build themselves and receive the output of the build the day after. Or not the day after, actually, whenever they want.
Another big challenge that we faced during the production is that we always wanted to have harmony between the uncrafted areas and the procedural areas. At the current stage of our production, more or less 75% of the world is Houdini generated, and the rest, which is 25% of the world, is uncrafted with love by the artist. Yeah. As you can see on that screen, the white areas are the areas that are handcrafted by the artist, and we tend to think that the artist will always, most of the time, always have prettier results than procedural paths, because, for example, they can put their camera at the right place or at the right angle and work the frame and the level as they wish. In order to be able to have the harmony between those tools, we had to make sure that the artist could erase any procedural work that was done in the world in order for them to put their little touch. And we also needed that the Houdini art team should have a result that is as high as possible in terms of quality, in order for the player to never see the junction and the differences between those two type of areas. As you can see on that screen, it looks pretty normal, but it's actually an area that is worked by Houdini and by the artist. So the artist can paint that pink layer on the landscape, and it will automatically remove anything that Houdini would normally place on that area. And finally, they can add anything that they want, for example, ferns or things like that. For example, for cinematics, if the camera go on that area and they wanted that kind of foliages.
So let's now have a quick overview of all the tools we created in Houdini. But first, we want to show you the different categories and how we connect the tools and the outputs. So we have three types of categories. The Optim tool that we created for performance reason. So if we have too much geometry at a point, we have memory issue, and we decided to create that pipeline. I'm going to discuss that a bit later. Then we have the Feeder tool. It's everything that will embellish the world. And then we created some tools for gameplay purpose where we spawn some, for example, some blueprints. All those tools will generate outputs, and those outputs will be stored inside levels. So for example, here we have Optim hand-placed asset, and you can see that it's going to be stored inside Optim XY. On top of that, we have everything that is placed manually by artists. So again, those scenes and those actors that are placed in those scenes will be used as input inside our tools. What is important to understand here is that the order of execution of all those tools is super important. For example, if you would change an asset, move an asset by hand, after that, if you want to rebuild everything automatically, we first have to launch that optimization tool. Here it's an example, but everything is like that in our pipeline, and you have to read everything from top to bottom. So yeah, that's the idea.
So let's talk a bit about the filler tools that embellish our world. Here you can see that we only have a landscape that is gray, and all the static mesh that you can see on the screen are hand-placed by the artist. When everything is hand-placed by the artist, we can then launch the first tool. The first one is the static mesh tools. What it will do is that it will fill the empty space if needed with some static mesh based on the biomes. When everything is hand-placed and procedurally placed, we can then go with the second tools, which is the paint tools. What it will do, it will apply the texture on the landscape based on those inputs, such as the rocks or the pine trees, but also with some noise or any rules that are exposed, that are used inside Houdini, such as slope or ambient occlusion or anything like that. The same tools will also apply runtime foliage, which I will explain a bit later, but what is it is it's very small foliage that will coverage a lot of large areas, such as the grass or the moss or even the pebbles. And the final filler tools that will embellish our world is the foliage tool. And what it does is, as it's said in the name, it will spawn a lot of foliage in our world, again, based on the inputs, which are the biomes or the pine trees and the rocks.
We also have some gameplay tools, and the first one that we want to present is interactable tools. So here we spawn blueprints, and inside the blueprint you have the logic that where the user, the player, can interact with this asset. If we went for that solution, it's mainly because we wanted to have more control and more knowledge of the environment inside Houdini, and also performance-wise, it's easier for us to spawn something at the right place. While at runtime, sometimes it's not always possible. The second tool that we created is a tool to spawn creature. However, we do not really spawn creature. We generate a CSV, and that CSV will be used by the gameplay team in order to for them to know where they can spawn a specific creature. So we went again for that solution because we have a lot of understanding of the environment, and also in a small team, you don't always have the possibility to put everything on gameplay team. So on our side, it was easier for us. We had some time, so we took that solution. We have that solution at the moment. The last gameplay tool that we decided to create is a mesh generation over the entire wall that is used by a feature to find the collision. So we decided to go for that solution because initially we were detecting all that information at runtime, and it wasn't working. It wasn't super stable. So we went for that tool where we create a mesh over the entire wall, and we use that collision. So the pipeline will assign the correct collision layer automatically.
All the tools that you just saw before are using static mesh as inputs. At the start of the production, we didn't have any problem with that. But as the game got bigger and bigger and the artist placed a lot of assets inside our levels, we had some memory issue and time process issue. In order to fix that, we created a new pipeline and a new tools, which is the optimization tool. Sorry. What it will do is that it will take those inputs and reduce greatly the poly count of those and also the numbers. As you can see, those white volumes that you just saw and that are still present here comes from those palm trees and the rocks. Now that you had an overview of our tools that we are using in our day-to-day production, we would like to talk a bit about the pipeline system that is hidden behind the scene. So we have two kinds of interface in order to launch our Houdini tools. The first one is inside Unreal, and that's basically the one that I'm almost using every day. As you can see on the screen, we can select any tools that we want to launch. Right above that, we can select the location where we want to rebuild the tool, which is there here represented by X and Y coordinate. The pro of that pipeline is that anybody can launch in the team any tools that they want inside Unreal 4. What's also great is that it will automatically, the default behavior will automatically save the output, the result on the level, and then if you are fine with the result, you can then push it on the server. What's also really amazing is that it will automatically fill the inputs inside the tools. Because at the start of the production, we had to manually select all the, for example, the rocks and put them manually inside the tools. And it was really time consuming and not very fun to do. So yeah, that's awesome. That's fixed now. And finally, we can also use it as a debug tool because we can check the logs inside Unreal and see if everything's fine. The cons is that we can only build one coordinate at a time, so only one X and Y coordinate, and it will block and it will kind of freeze Unreal. You can't use Unreal at that time, so you have to find another stuff to do. And finally, you can't chain pipelines. Another feature that we developed is the debug functionality. We created this in order for the user to stop the pipeline at any key moment. For example, if we want to debug, the user can ask to the pipeline to stop the tools at right before he will remove the tools from the levels and close the levels, in order for us to use functionality that is inside Unreal, which is the open scene inside Houdini. What it will do is that it will open the tools inside Houdini with all the inputs that we've put inside the tools and with the output result. It's crucial for us for improvement or even debug purpose.
The second tool that we had to develop is a connection that allows our team to rebuild on the server and the render farm. So that system is only a Google Sheet. So yeah, we are a small team, so we are using like simple tool. But I saw yesterday a talk about Epic, and they are also using Sheets, so we are okay. Chain pipeline is allowed with that system, so we can like build several pipeline at a time in one batch. The user can decide which coordinate system, so which coordinate they want to rebuild. And yeah, they can build anything from their bed, so they only have to say to start, and then it's going to rebuild automatically. The second interesting thing that we had a problem that we had a good global overview of all the pipeline, because at a point we had 2,000 pipelines to rebuild all the time for all the tools separately. To have a good vision on that, we have that success and failure information. That is crucial, because from there we can just rebuild, check if when it happened with the second column, the J column, and then after that take the build number and start debugging and see which problem we have. The last feature that we have in that tool is that anybody can set a specific date where they want to rebuild at any moment. So it could be like during the weekend or whatever. Now how do we link that Google Sheet to the render farm? We are using Jenkins. For those who don't know, Jenkins is an open source automation server, and Jenkins will check if an agent, so an agent is a computer, if an agent is available, and if it's available, it's going to launch the process. Jenkins is in charge of several stuff. First, it syncs the project automatically. If we do that, it's because we always want the project to be up to date. Otherwise, we don't have the correct result. Let's say someone change an asset. For sure, you want that asset to be changed when you rebuild a tool. Then we build the project to be sure that it compiles, and we launch the pipeline. We will go in detail right after. The last step that Jenkins does is we take the output of the pipeline and we send that to Perforce automatically. In order for Jenkins to launch pipeline, we always need the same entry point. So what we call entry point is what we call entry point is one way to launch several pipelines and not like several scripts. We have like several person and several possibilities, and we want only one place to handle everything. The pipeline framework is generic in the sense that we have always the same flow. So we have an input, then we have an output, and in between we created some space where anybody can write scripts and set settings around that. So from there we can build any pipeline and do anything. For us, it was super important to develop that system because we are a small team and we cannot manage like having script everywhere. So it was vital for us. And also, it's the better way for us to integrate any code written by anybody, and then we launch that code in general. If we are using Python, it's because it's integrated in Unreal automatically, so it's easy for us. We can integrate that with Maya, with Houdini also. So yeah, it's pretty easy to edit. In terms of how we connect Houdini Engine and Python, so our pipeline framework launches Unreal through command line, and the idea is that the system of Unreal allows to launch a Python script, and that Python script is the Unreal pipeline framework inside Unreal. That script specifically is the twin of the pipeline framework, okay? And it's gonna launch all the steps all the time. So it's gonna handle the same step all the time. The communication between those two scripts, because it's two different processes, we are doing that through a JSON command file. And the JSON is basically the description of the pipeline, and then we make the communication to know if there is a problem. We also use that JSON command file. Specifically, in that Unreal pipeline framework, we always have the same steps. First, we load the levels. Then after that, we have the Houdini routine. Yeah, a Houdini routine is really where the custom script is written. So here it's Houdini, but we could also like do a rebuild nav mesh, and it will work properly. And in our case, because we are speaking about Houdini, we first spawn the Houdini actor inside the level automatically. The Houdini actor is the actor that we are using, that if you know the plugin, it's provided by the plugin for us to fill everything. Then we fill Houdini inputs inside that tool. Then we cook Houdini tool automatically with Python, and then after that we bake the outputs. At the very end, we save the scene that's been modified, and then we unload all the levels. Now, the Houdini Engine and Python are not really working. Yeah, it wasn't fully working together, so we had to change a bit the plugin in order to avoid some crash, and also to be sure that the cooking was working properly. So we are faking that cooking, and it's why we created that Houdini Engine wrapper, because our custom logic, we want to keep that as much as possible outside of the Houdini Engine. Because when we update the plugin, because we try to be as close as possible as the new feature that they provide, we don't want our logic to disappear, and it's way easier to maintain for us. We also have custom behavior. So for example, the baking, we have custom logic when we take the asset that's been generated by the plugin and then move them to the scene. We have some specific logic for our pipeline, and we want to keep that also, so we store that inside the wrapper.
So in order to let my coworker breathe a little bit and drinks if he wants, I will explain a bit about, I will talk a bit about the thing that we are using to launch our tools. To do that, we use a JSON config file, and inside of it, you can see that we are beginning by listing all the levels that we need for that tools. We need those levels because all the inputs are inside those. Right above that, we have the default scene where we are going to put the Houdini tools, and also where we are going to bake the output. After that, we will list all the inputs and the tags that we will be linked together in order to work. We use this kind of JSON config file because it's very easy for us to work with. It's not to the developer to fill this file, but to the Houdini art team. So yeah, it has to be easy. If we want to create new tools, new pipeline, we can duplicate this file, change the list of the level, the default scene, the inputs, and all the stuff like that. It's also very useful for debug purpose. For example, if we have some problem with some inputs or with only one level, we can remove all the other levels in order for us to launch the pipeline with only one kind of level to gain a lot of time.
When we speak about inputs, for us, an input is an actor with some tags on them. So we place tags manually when it's manually placed asset, but for for asset placed procedurally, we are placing the tag automatically. Houdini actor has parameter with specific name that is defined by the Houdini team. So when they create their tool, they will set a name here. For example, I think it's world collision rock. And we use, again, that config file to link them together. So the pipeline will feed the information, will get the tags, all the actors with those tags, fill that inside the tool automatically. We have a convention at Appeal that for all our inputs, so if you know the difference, there is a difference between input and parameters, we always set the landscape as an input. What's important to understand is with that system, we have consistency between all our tools. So we can have different tools, but they always have the same inputs. So we can work on the same foundation. And when we create masks, for example, we always have the similar masks.
Now let's talk a bit about one of the most important inputs that we have in our games. In our game. The first one is the biome volumes. They are hand-placed by the artist inside the world. As you can see on the screen, we have, for example, the orange volumes that represent the desert biome. We also have the green boxes that represent the forest biomes. Yeah, they are either placed by hand with basic shapes, but we also have a basic Houdini tool that will create more strange or less basic volumes. Those are very important because they will bring a lot of variation inside our environment. Next biomes, next inputs that are important are the subbiomes volumes. They are kind of the same than the biomes, but at a smaller scale. So for example, here we have the pink sphere that represent the flower biomes. And basically, those are inside the forest biomes. And even if we have already a lot of variation inside our biomes, at some point, the artist wanted to have even more key location or variation inside those biomes. So yeah, they can also place those biomes, add the tags, and then the Houdini tools will process it. The final inputs that I will talk here, and is almost the most important one, is the no-go zone volumes. We created those because, again, at some point, the artist, we wanted to give them as much freedom as possible. And in some areas, such as, for example, the villages, they wanted to create and to handcraft the villages at 100%. So in order to do that, we created those volumes. Again, they are hand-placed. They had a tag which is no-go zone. And what it will do is Houdini will import it, create a mask out of it, and remove anything that is procedurally generated in order for them to work freely in those areas. It's also the same, kind of the same with the roads. We are placing a curve that will generate a cylinder, and it will remove any foliage inside of it. So we make sure that there will never be any foliage on the path, and that roads can also affect the texture on the ground.
Outputs, we do support several types of outputs. When I say support, it's because the plugin, the Houdini Engine plugin will output some stuff, some actors or some instances, but on top of that, we have to support that inside our framework, for example. And if we don't do that, sometimes we cannot bake or those kind of stuff. We have landscape layers that allows us to paint on the landscape. We have static mesh instances. We can spawn blueprints. We can spawn hierarchical instance, static mesh foliage. So we can also generate static mesh for collision. We discussed that before. And we can generate CSV from a tool. Yeah, so let's switch to what another topic like in-depth tool. The first one is static mesh tool. That one will add big rocks and trees inside the world. First, let's have an overview of the tool, just for you to understand that we have inputs. We already discussed that, but yeah, it's always the same inputs. And then after that, we create some masks from those inputs. And at the very end, we spawn mesh. We spawn mesh based on points, and when we say we spawn mesh, it's more we add a tag inside. It's a functionality inside Houdini that allows to say, okay, I want an instance, and it's going to spawn that with the Houdini plugin.
All our tools are using the same logic as inputs. We have either mesh inputs, such as rocks on the left of the screen, and we also have mask inputs, which is represented here by the red mask that you can see, and is representing the cliff texture that is imported from the Houdini landscape. Now let's show you a bit how we are creating the mask and how we are spawning rocks inside that mask. So at first, we are starting with by using any inputs. In this example, we are using the mountain biomes, which are represented by a big sphere, and we are going to use a mask by object node to create a mask at the junction of the sphere with the landscape. After that, we are going to apply a distort node, in order to remove the straight junction that was created by the sphere and the landscape. We can then apply, for example, here a blur and even another distort if needed. The next step here will be that we subtract any mask that we want. For the example here, we subtract the cliff mask, for example here by slope, because we know for sure that we don't want, for this example, to spawn anything in too high slope. The next one is to use a shrink and expand node with the same value in order to remove all the small spots on the mask. Another node that we are using in this example is a noise that we will subtract on the mask, because we don't always want to fill all the masks that we created, because sometimes we want to let the environment or even the player breathe in some area and not fill it with too much big volumes. And the final one, which is the most important one, is to subtract the no-go zone mask that we created from the volumes that we showed before, in order to never spawn anything inside those. Now that we have finished to create the mask, we are going to spawn and scatter the point on that red mask that you just saw before. In order to do that, we are going to use a height fill scatter node that use as input 1 the landscape and as input 2 the mask. and it will then spawn point on that mask. We can then play inside that node with a lot of value. For example, the coverage, which represents the density. We can also play with the outer radius, which represents the distance between the points. So if we have big trees, we don't want them to overlap, so we will increase this value. And if we have small bushes, they can overlap, so we can decrease this value. We can also play with the range, which represents the scale and many other parameters. When we are finished with the spawn of the point on the landscape, we then have to make and create a selection of those. Because for this example, we spawned point based on the mountain biomes, but we need to make sure and to know if that point is on a sand texture, on a grass texture, or on a sand, or on a snow texture. In order to do that, we will create a selection based on that texture. And here is on this example, if the points are inside the mountain, the snow texture, it will be on B1 selection. If it's not, we will check if it's on the B2 selection, which is represented by the sand texture. And finally, if it's neither in those two selections, it means that it's in the plain biomes. And then we can link the right version of the rock, which will be the mossy version of the rock. When we are finished with the selection of those groups, we can then link the asset that is inside Unreal to the point that we spawned inside Houdini. In order to do that, we created our own basic homemade node, in which we are listing all the assets that we want to spawn by using the path from Unreal Engine. And the small vex expression right above is only for some randomness between all that list. The final step is to link the right tag to the right asset in order for the next tools that will go after to recognize if it's a rock sand, if it's a snow sand, or if it's underwater or anything like that.
Let's now discuss a bit of another tool, the paint tool, so the one that will paint everything on the landscape. As you can see, we have the similarities between the previous tool. We have inputs and mask creation. However, we have two more features. The grass mask creation that is used to, we create a mask and then we feed that inside Unreal, and the vegetation will, it's not vegetation, it's grass, sorry, will be spawned from that mask. The other one is one Houdini mask will be set as one Unreal layer.
So what this tool can do is that it can apply texture on the landscape using, for example, here, any noise that we set up. We can also apply texture based on the inputs. So for this example, we have a big tree, which a tag tree that the artist put on it, and Houdini will recognize it and can apply a different texture, for example, wood texture right there. We can also spawn moss foliages, which are the grass foliage, which is the runtime. In Apple Studio, we call it runtime foliage because it's spawned at runtime. And I will explain this now. Here is an example, and that's inside Unreal. What it does is that we will take any layer that we want, for example, the grass layer from the landscape material, and then we will link it to the beige section, which is the grass system from Unreal. The last column is all the static mesh that we can link to that grass system. And so we can list all the static mesh, here for example grass, and all those static mesh will then spawn on the right layer, that is the grass layer. As I said earlier, we always wanted to give as much freedom to the artist in order for them to work properly. So at some point, they asked us to be able to remove that grass on the ground, for example, to change with moss or pebbles, or even to remove it for gameplay purpose, for example. So we created a new layer inside the Unreal material that will automatically, that we called remove foliage layer, and remove for runtime foliage, sorry, that will remove all the grass that we spawned inside the material. All that subtraction is done at runtime inside the Unreal material. At the start of the production, we had one issue. As you can see, we had two landscapes for one location. On the left, we had the gray version of the landscape in which the artist was working. He can paint anything he wants on that landscape. And we had another landscape at the right, at the same location, which was the Houdini landscape. And what it does is that it will take the first landscape as input, take all the information that the artist painted, and then create a new version with the Houdini path and the hand-painted path. We had those two landscape because at first we only had one type of layer. So for example, we only had one grass layer on the landscape. We quickly noticed that it was not a viable solution for the artist because they couldn't see the Houdini result because it was in another level. So when they were working on a gray landscape. So in order to fix that, we decided to have only one landscape for them to work. And in order to do that, we had to duplicate all the layers that we had. So before we only had the grass layer, but from that point we had the hand-painted grass layer and the Houdini grass layer. So at that time they could work with the Houdini result and paint. They only used the hand-painted layer to paint the landscape. The pro of that is that, as I said, is that they could see the Houdini result. But the cons is that we had to create a new pipeline, an extra pipeline, because as you can guess, it was not quite optimized because we had duplicated layers on the landscape. So that pipeline, we won't talk about it, but what it will do is that it will take the landscape with duplicated layers and merge them in order to have only one grass layer landscape. And the final step that we had to make sure for this solution is that we needed to make sure to never erase the painted version that the artist painted on the landscape. So in order to do that, before we linked the mask from Houdini to the layer inside Unreal, we needed to make sure to subtract the Houdini layer by the hand-painted layer in order to never erase their work.
I'm going to be quick on that problem because we are short on time, but same problem, we fixed that recently. As you can see on the left landscape, we have a work texture that is applied, and on the left one we have texture applied, and on the right one we don't have that texture. The problem is coming from that the input is based on the pivot point, and the pivot point is passed per the landscape. So the right landscape doesn't have that asset loaded. To fix that, we decided to add more input, so to pass adjacent landscapes and adjacent static meshes. The problem with that is the memory, and it's why we came with optimization tools, because it's too much assets to pass to the system in one go, and it wasn't working. So it's why we have the optimization pipe. The result is that one.
Now let's talk a bit about other tools quickly. At first, the next tool is the Foliage tools. It's very important to embellish the world, but the difference between that tool and, for example, the static mesh tools, there is basically no difference, except that we don't spawn anymore static mesh, but Unreal instance foliages. But otherwise, we are taking inputs, creating mask, spawning point, linking it to a foliage. Again, the artist wanted freedom and wanted to be able to work freely. I've already talked about the no-go zone volume that will erase any procedural work from Houdini, but in some case they wanted to have this function at a smaller scale. So we created another layer. It's kind of the same than the remove runtime foliage, but it's the remove foliage. And what it will do is that Houdini will retrieve that layer, that mask from Unreal to Houdini, and that mask will subtract any mask that we will create to spawn foliage. The foliage tools helped us greatly to integrate even more the static mesh inside the landscape. Because yeah, for now we applied some texture, but as you can see here, we have a big trees that is not quite great integrated inside the landscape. So yeah, it helped us greatly. Houdini is taking that input, and we will spawn big foliage at the base of the static mesh. And the more we are moving away, the smaller the foliage will be. So yeah, it helps us a lot. One of the final tools that we created is, we talked a bit about it. It's the optimization tool. And as you can see, we start with 4.6 million polygons and 360 rocks, and we end up with 100K polygons and 1 rock per tag. So quickly, what it does is that, for example, we take a rock, we will poly-reduce it in order to reduce heavily the poly count of that mesh. We usually only retrieve and keep 20% of the poly count. We then will create use a polyfill node in order to remove any hole inside the mesh, because when we were creating some masks, sometimes with holes, we had some problems. The next step is to select any geometry that is under the landscape, because we never have the use of those. And we will blast them. We will delete that geometry in order to optimize the mesh. And the final part is to delete any small chunk that is not used for the mask creation.
The last tool that has different behavior, we create the same thing. We want to create some CSV. We already discussed about that, and how we do that. We generate points from mask and inputs, but we use a PDG node to generate the CSV. There is support now inside the plugin, the Unreal plugin, and it was working like straightforward. We had that node, and it generates the CSV automatically. We pass as an input the path of that CSV, so we know we can customize where we want to store that CSV. Let's now wrap up what we learned. First, Houdini can be self-taught thanks to the documentation and really great tutorials. So if you are an artist, don't be afraid, or if you are alone, don't be afraid. You can learn thing. It's gonna work. We also learned after 3 years working on Outcast 2 that open world procedural asset placement can be achieved by a small team. It's working, and it's not only speeding up the process, it adds quality inside the world. It's more an advice, but sometimes you think it's impossible, you cannot achieve something, but try to split your work and really split your work, and the wall that you are facing is gonna disappear. So it's really, and also think about prioritization. It's also really important. The last point that we want to say is we learned that it's super important to listen to our users. So we are developing tools, and sometimes like what you saw with the gray landscape, it wasn't working, and at the beginning we didn't listen to the artist team. And at a point we received that information, and then we created a better tool. It helped them to work faster, but moreover they were way happier to work with the tool that we provided.
What's next? Finish Outcast 2, and we also would like to create more tools for example, our next production because yeah, at the start of the production, we didn't know Houdini, so we didn't have the possibilities to create, for example, the cliff, some cliff tools or the river tools in order to have a flow map and even place some particles where the rocks are inside the river. So that would be awesome to create even more tools for the next production, now that we know Houdini. Also, same kind of point, but we didn't know Houdini, so we created our landscape inside Wall Machine. And yeah, that would be awesome to create the landscape inside Houdini and to get a lot of data from it, from the erosion, for example. So yeah, we want to have a look at that. And finally, one big point is that at the start of the production, again, PDG wasn't available for Unreal. So we would like to, for the next production, to have a look at PDG to see if we are jumping and using the PDG from Houdini, or to have a look at it to see if we can take some stuff from the PDG to integrate it to inside our pipeline. Thank you very much for attending our presentation. If you have any question, feel free to ask us. Yes.
No.
Hi. For the foliage tool where you're scattering smaller and smaller foliage away from the tree, how are you preventing overlap but like maximizing volume?
We usually create a first mask that will spawn big volumes, and then we expand that mask, and we will subtract the first mask to the second one. So yeah, we usually don't have overlaps, but in some cases we accept some overlaps for the brushes. They can overlaps, even the rocks. So yeah, sometimes we have overlaps, but as we are subtracting masks with each other, we don't have too much of that.
Thank you.
You're welcome.
Yeah, well, first, thank you for the talk. And so for some of these like no-go zones where the artists are really wanting to place like handcrafted things, do you also create sort of like asset generation tools in the engine that the artists do use in those to like, I don't know, maybe like more like viewport curve-based tools that artists like, you know, create actual meshes in the engine with?
For visual assets? Or
yeah, for visual assets.
Yeah, we created some of them, but as we are a small team of Houdini artists, we didn't create a lot of them. But for example, we created some suspended bridge in order to create bridges with custom length inside the forest. We also have, for example, barrier, fences, tools, and stuff like that. But yeah, we focused more on the placement of big volumes, foliage, and painting on the open world. But yeah, we had some of them.
Right. Awesome. Thank you.
Thank you. Thank you for listening.
Yeah,
for having
thank you.
have listened.